So I guess everyone has heard about WebRTC. Who hasn't? Okay, we're good then. So I'm going to tell you kind of our story of where we plan to end with WebRTC to enable our infrastructure. As Rafan said, my name is Saúl. I live here in Amsterdam now. I go by @Saúl everywhere, so I probably interacted with a bunch of you guys on my mailing list. I work at AG Projects, and we have been long-time supporters of OpenSIPS. We have done a few modules, and we do a bunch of software related on the side of OpenSIPS. Mainly, we have been doing a SIP client called Blink, a SIP application and conference server called Silk Server, a media relay called Media Proxy, CDR tool, and we do other things like call control. Whoops, not that. Yeah. A second, please. And that was hard. So we have other pieces of software as well, like call control or OpenXCAP. These pieces of software have allowed us to build a platform that we have for public use, which is SIP2SIP. This is the kind of platform we sell to our customers as well, to do all sorts of instant messaging, presence, all the services that you might need. We have it available as a testing tool for free. So we don't necessarily cut on features because, of course, all these features need to be implemented by the endpoint. That's how you actually have an audio call. I don't need to enable anything. However, we do need to enable non-traversal and all those things. So whatever that was kind of on the SIP beyond VoIP kind of era, we tried to implement in SIP2SIP and enable it for others to play with. We have seen all sorts of crazy stuff in there, like, I don't know, SDPs you won't believe, and the brokenest SIP that I've seen in my life, it has been there. But, oh well, that has helped us fix bugs in OpenSIPs, in related software, and so on. We have seen some usage growth a long time. This is not, we're not planning to conquer the world with this. This is testing for us to learn what people are doing, what people want to do, and what we want to do as well. And then, circa 2012, WebRTC came. So probably everyone wondered, okay, so what do we do now? What's our story? What role does WebRTC play? What is it? I think it's actually many things, and depending on how you look at it, you can act upon it in a different way. So on one side, it's a standard. Well, not yet, it's a proposed standard, but it's going to get written in the important papers, let's say. The RFCs we like to quote on the mailing list to say we're right. So that means we will have to do something about it. It's also a project, and this is where things have gotten pretty cool. It's a project that Google open sourced, and it has got great code in it, coming from Google's acquisitions and what have you. It's some valued in the $60+ million kind of place there. It has some very nice things inside, so very polished audio pipeline, for example. For Blink or SIP client, we kind of borrowed the echo canceller, noise cancellation, and acoustic gain control from WebRTC, which means suddenly you can kind of shout at your computer and it works, because they took care of it. So it's great because it has a very liberal license, so you can kind of do whatever you want. These days, there are also alternatives. There's Open WebRTC, and we all know that everything is better if it is open in the name. So that's good. It's also a new media profile. So WebRTC has nothing to do with signaling, really. It actually leaves it open, which is good and bad. I'll go into that a bit later. It just defines a number of ways or a number of things we need to do to get media up to a given profile. Most of all, it's also a mess of an SDP. I'm not sure if you've seen it, but a WebRTC SDP is so huge and so convoluted, none of your SIP devices will chew it these days. It's pretty horrible, and the fact that they chose that is pretty much a bit of nonsense, but it has happened, so we deal with it. But the one thing that it did bring is a big change, a changing in the paradigm of how peers find each other. We, the SIP people, were used to this trapezoid kind of paradigm. So if Alice wants to call Bob, and Alice is in Atlanta and Bob is in Biloxi, well, each will talk to their server, and then the servers will find one another, and we have this federated world where each can run its own server, and then we can talk to each other. We do the same with email, XMPP, you name it. However, WebRTC, it's a web thing, hence the name. So it's a triangle paradigm. The only way two users meet is if they're visiting the same website, or if they happen to click a link that drives them to the same place. So a Facebook Messenger user can only reach another Facebook Messenger user if they're on the same webpage. Same goes for Google Hangouts if they're using this non-kind of gateway thing they did to XMPP or whatever. So it changes how we're doing things. And this is important because lots of the things that we do in SIP kind of may not apply anymore because we changed this to this paradigm. Now, I said there are some new media features. Here are just a few. So WebRTC mandates the use of ICE. ICE is not new. We were actually doing ICE long before that, but it has kind of popularized it. Also, it added on top of it, so now there's trickle-outs. For those of you who may not be super familiar with what this is, ICE allows you to kind of poke into what is the best path for two endpoints to communicate and try to sidestep the relay and have peer-to-peer audio. And trickle-ICE improves on this by allowing you to first send the SDP and then send all these media candidates incrementally, and thus reducing the call setup time. This is kind of important in especially kind of mobile scenarios where you want to call someone and you don't want to wait for 3 seconds without audio until, well, something happens and some server is queried and then finally there's audio. Another thing WebRTC added is DTLS support, or, well, rather DTLS authentication for SRTP. Not my preferred way of authenticating SRTP. However, it does add something very interesting to the table, which is if you're using DTLS, there is a way for you to have an end-to-end encrypted meeting session, which you can verify, and you can do it in a perfect forward secret way. So nobody can actually, even if somebody captures all your traffic and then the police comes and raids all the servers, they cannot decrypt the data inside. Which is not the case with traditional SDS-based SRTP because the keys are used all the time and go on the SDP, so you could decrypt the whole thing. It also added bundle. Bundle is a way to group streams on an SDP, making it nastier as well. And RTCP muxing, this is an interesting one, and this is also mandatory if I recall correctly. It basically says that you do RTP and RTCP multiplexed on the same port. This is nice because it also reduces the resources you need on the server to keep all those ports open. But I think most importantly, what WebRTC brought is that it made many of these features mainstream. So not many people were doing ICE, but now because WebRTC mandates ICE, well, if you take baby steps, the first thing you would do maybe is, okay, let's add ICE. then let's add this, then let's add that. So suddenly we have a lot more SIP endpoints that can do ICE, and that is a great thing, despite WebRTC. It doesn't really matter, it's just an objectively good thing to do. Also, codecs. WebRTC mandates Opus, and Opus is like the best codec ever for audio so far. And well, as a result, also many endpoints started to support Opus, which is also great, because once you go Opus, there's no way of going back. It's, oh yeah, it's 729 low bandwidth, that sounds like crap. If you use Opus, you get full bandwidth. If you have lots of bandwidth, you have little bandwidth, it adapts kind of live. So it's a very smartly done codec, and it's great to use. There was a video codec war in the WebRTC universe, so H.264 versus VP8, they kind of settled in that you have to do both. But I think this kind of helped also the adoption of VP8 as a general thing. So the thing with all this is that we cannot really ignore all this that's happening. We are in a VoIP/SIP industry, whatever you want to call it. But we need to embrace some of this. We can't really ignore it. We are kind of doomed to being forgotten. So new applications, web or otherwise, will be built by either using one of these toolkits, because honestly the WebRTC stack is great as a media stack. So if you're developing an application, suddenly you have this C++ library that can do wonders if you that can generate an SDP and you find a way to send it to the other side, and then both endpoints can talk to each other. So suddenly you have all that code available to you. It's high quality, written by tons of people, and you're not paying them. So that's great. There is over 1 billion of browsers that have this built in. So Mozilla, Google, they are aggressively pushing this to you. So it's not that you can ignore that every browser has the ability to already be a rich media communication endpoint. You can't forget this. And Google Hangouts is using it, Facebook Messenger is using it, so there are big platforms that have been deployed, so it's kind of becoming more of a proven technology. So it means that it's time to adapt and build something that can accommodate all these devices. As Bogdan said in his introduction, OpenSIPS is getting SIP over WebSocket support, and that's great. But I have some mixed feelings about SIP over WebSocket support. It feels right and wrong at the same time. And it's kind of funny that I say it, because my friends wrote the RFC, and I'm quoted there because we talked about it. And the thing is, in the environment where you would use SIP in a browser, some of the things don't apply. Even something basic like authentication. If you go on a website and you're already logged in, you don't need to 407 the invite, because you already know who the user is. He is on the website already. So do we really need to re-authenticate? We can pass cookies along when you create the WebSocket connection. So some things just no longer apply. Do we need VIAs? No, because in the end you have this client connecting there. Of course you already know where the response needs to go. So some things just feels like a bit shoehorned. So we have this thing that some people like to call legacy these days, and we're kind of trying to forward port it to the future. And web guys don't like it. The web people apparently didn't buy into this. And the XMPP people also tried. There are ways to do XMPP on a browser, but what people are doing more and more is their own custom thing. Also, probably in the past decade or so, so somewhere before this whole WebRTC thing happened, things have been changing. Presence has changed. So we probably all have made this joke at least once: simple is not simple. So the whole presence model in SIP was architected in such a complex way that I'll probably leave shorter amount of time for all the time I spent debugging issues there. And the thing is, now we use it differently. It's not like device-driven presence anymore. We are always online, really. Which is that sometimes we can audio and sometimes not, so we use text, but we're always online. So this per-device presence thing, does it make any sense anymore? I'm not sure, but it sounds like no. Instant messaging also changed. So it's not like we're sitting in a computer and we type some stuff and then we get up and we go to a different device. We have a variety of devices at our disposal, and we start a conversation somewhere, or we continue somewhere else, and we need to have everything available to us. And this is something Skype got right early on. So they had like your presence, not your device's presence. They had that, and they also had this synchronized chat history, and you could continue conversation from anywhere. And SIPs, what we are supposed to use in SIP, MSRP, which is a protocol I'm fond of, kind of doesn't cut it so much. So we also need to accommodate for that. So in the end, what the web people did is they went all custom. So you grab GitHub and you find easy WebRTC, super easy WebRTC, hello RTC, I don't know. You name it, there are tons of them. And maybe they're right, because they cut all the complexity, all the things they don't need. They just took it and worked with it. So maybe we can do better and do something similar. So what we chose was to sort of embrace all this web era and use the protocol of the web, let's say, which seems to be something over JSON, and which is the language of the web. And then my idea is that because we've been doing SIP, we will keep SIP at the core of our network. We connect all the other devices to it, and then we just need to enable the WebRTC endpoints to join. But instead of adding the burden that SIP might be, we can do it in a simpler way with a protocol like that. So how we are dealing with it is as follows. So I'm using two software components here, Silk Server and Janus Gateway. So Silk Server is our SIP application server. We started developing it a few years ago. It started as a multi-party conference server, but it then grew up to be kind of a whole thing. So today it allows you to connect SIP networks and also XMPP networks. So we already kind of started the idea of gatewaying protocols that we don't understand to protocols that we do understand. SIP is kind of our bread and butter, so we take XMPP and bring it to the SIP world. This means that all those features that are there, like conferencing, high definition audio, etc., are suddenly available also to the XMPP endpoints, because we did some translation. So we understand SIP, so let's build the core with it, and then we just transform what we don't understand to what we do understand. And the second part of the puzzle is Janus, which is a customizable WebRTC gateway. When I started doing some research on what was there available, the main ways of doing this, I believe Livia Rosvan will show you tomorrow how to do it with RTP Engine, which is a different way. Janus is a standalone piece of software that you deploy, and it's a WebRTC gateway. So what does it do is you connect to it with your browser, and it has different features, like it gateways to SIP. It can also do a video MCU to mix video from multiple sources, and it has a number of plugins. It's still in the early stages of development, but it's very small. It's lightweight, written in C, so it's on the same realm of the things we're doing here. And I liked it because it, like he said in his talk right before me, it does one thing, but it does it well. So one thing I like is that they can contain the complexity instead of trying to spread SIP all around. Maybe if we contain the complexity of translating the WebRTC to something any other SIP endpoint can chew on one component, we can simplify the rest of the infrastructure. So we describe all our presence, we use OpenSIPS, and we do all the routing, and that's fine. But how you join the network, if you are on WebRTC, you just go through this box, and then the rest is already taken care of. This is sort of the idea. This project is also used at IPF as a remote participating enabler, let's say. So it's been battle tested. So we chose to stand on the shoulders of giants this time, the same way we built our infrastructure with OpenSIPS. We chose to use Janus in combination with Silk Server. So Silk Server will kind of control Janus. It will be running as a hidden thing, let's say somewhere in the infrastructure. Here is sort of a sketch. You are able to access the Silk server's core capabilities. You can either do it via SIP by starting a call to it, and then you can join a conference or what have you. And you can do the same from XMPP, because once you cross the gateway application, you have access to the same features as a SIP endpoint has. And now we're adding, by calling the Silk RTC API, it's a WebSocket-based API. And with this, you'll be able to join from WebRTC endpoint to all the capabilities that are exposed by the Silk server core, which are multi-party conferencing, file transfer, etc. We'll just need to gateway those features one by one until we are on par. And all this is supported by kind of two engines. So one is our SIP-Simple SDK. This is the SDK we designed and implemented as the core of Blink. So this is what implements our current MSRP chat, file transfer, screen sharing, audio and video calls and everything. That's our core. And then we will use Janus as the core for the WebRTC endpoints. So all Janus has to do really is deal with the SRTP, DTLS, and Trickle-Eyes and all that from a browser and convert it into a SIP packet that we can understand, and we bring it into the system. And Silk RTC will be this kind of convenient JSON-based API that we use from the browser in a nicely packaged JavaScript. JavaScript library. So from a different angle, this is how it will look like. You have your kind of SIP network of devices which talk directly to OpenSIPS, and the way you communicate with the WebRTC devices are via Silk server. So you can actually kind of draw a line here in the middle and look at all your routing decisions and everything on your OpenSIP side of things, and the WebRTC endpoints will just join the network as another SIP endpoint through Silk server / Janus in this case, but they will look just like any other SIP endpoint. So the added complexity of our OpenSIPS setup is virtually zero, because the people that can work on the JavaScript libraries or on the whatever on Silk server, that's maybe me and Timon. So we will do that, and then you don't need to take care of it. You deploy it, and the endpoints join the network, and the service is available and has a new capability that it didn't before. But all the complexity is contained somewhere else, so you don't need to take care of it. I have a demo in a video form. I didn't know how the network would be like, and the code is pre-alpha state, so I'm just going to show it to you. We're going to see two different ways, the two kind of sides. Here I'm using Blink to call into an endpoint that is connected over WebRTC. So that's me, I'm doing a normal call, dialing a SIP address. And that's Timon there at my place, drinking the success glass. So there in the small letters we can see that the user agent in this case is the Janus WebRTC gateway. So this thing got connected to an endpoint that was in a browser. Actually it was Firefox Developer Edition, as we can see here. And now we're going to do the reverse. So here we are registering, we're putting our SIP credentials, and now we can just dial any other SIP count. So these are, we're toying with SIP to SIP info. And once we give access to our devices, we'll begin a video call. First we kind of see ourselves, and now we flip the view to the remote endpoint. So kind of success glass again, I hope. This is sort of how easy we want it to be. The idea is that you just use SIP addresses just like you did before, and from the client side, you don't worry about it. Now this has kind of some challenges because, for example, on that demo we were using Firefox Developer Edition. Why? Well, because there's apparently, I've been told on Twitter that I hit a combination of bugs that prevented the thing working on Firefox 38 or so. So the Developer Edition had these bugs fixed. Also, Firefox is currently the only browser that has H.264 implemented, but there's also an opt-in. You need to like flip a switch to enable it on WebRTC. So part of what I hope to be working on soon is adding VP8 support to Blink so that we can also talk with Chrome or with Firefox itself if you're using the VP8 codec from the browser. Because really web developers, or any developer really, you don't have all that much control of the capabilities you have on your WebRTC engine. You just use what you're given. So if it has that codec, then fine. The idea behind all this, which I kind of forgot to mention a bit, was that Janus doesn't do any transcoding, which for some it's a feature, or sorry, for some it's a bug. For me it's a feature, because it means it's a lot more lightweight. It just forwards the media. So if your SIP endpoint can do Opus and VP8, fine. Otherwise, well, I'm sorry. You buy it, man. This is how it kind of works in my mind. Now, WebRTC also mandates the support of G711 for sort of PSTN backwards compatibility or something like that. So you will be able to talk to a degree at least. You won't enjoy Opus, but at least there will be something. So I said in the beginning that we implemented all these kind of SIP beyond void features in SIP2SIP.info in our clients. So WebRTC only kind of solves a bit of the problem. It adds browsers audio and video support, and then there's the data channel, which kind of has spawned a lot of innovation, but it doesn't solve all the other problems like chat or presence or what have you. So our way to solve this will be, again, embracing the web technology. My plan is to have a translation between all those nasty presence XML into some easily parsable JSON documents that the browsers can use. So this is something, we don't want to work with XML in the browser. It's just not worth it. So we'll simplify. Presence, we can probably make it simpler in such a way that JSON is enough to represent it, and this is a lot easier to work with from the browser. So we'll do that. Then context management on kind of our SIP world is complex, unnecessarily complex. It uses the XCAP specification, which means you store your address book in an XML document on a server, and then you modify it using like a RESTful API with XPath expressions and things that give you nightmares. So we'll also simplify that by, at the core, we'll still use OpenXCAP and all those things, but from the browser, you'll just get some JSON with all your contacts, and you make changes, you submit it, and then we already modeled all these changes because Blink implements it, so we already know how to deal with it. We'll just expose it in a nicer way. So you can kind of see the trend of where I'm going, right? So we embrace the web technologies, we use JSON for this, JSON for this, JSON for that. I'm not sure what we're going to use for chat though. Seems like it's the easiest part, but it's not clear to me yet. There's a draft on how to do MSRP over WebSockets, and there's another draft on how to do MSRP over the WebRTC data channel. But I'm not 100% sure that MSRP is necessarily the right tool for particularly the web job. So between desktop endpoints, I like it. On the web, not so much, because we have very volatile endpoints that you open a tab, close a tab, open another one, close another one. So it's not like they stay for long sessions. You do quick one-off kind of messages and things like this. So we'll probably need to figure something out, which is a little bit the beauty of it. We'll figure out as we go. So I hope we can upload our alpha code soon to silkserver.com, and we will deploy it on WebRTC.SIP2SIP.info, which is right now has a coming soon landing page, I think. And the idea is that what will be deployed on SIP2SIP.info will be something that you will be able to test by yourself with your SIP2SIP.info account, which is free, and you'll be able to dial any SIP endpoint because there is no real limitation there. And then once you see it, like it, whatever, You can then download it and deploy it to your own infrastructure if you want to. So that's all I got for today. That's my contact website if you have any further questions. I'm open for questions now. We'll be later at the event as well. So thanks for coming.
Anybody have any questions for Saul? Nobody?
Okay, I'm super clear. Thanks.
Thanks, Saul.